Welcome to the Legal Brief. Today, we are taking a radically different approach to your exam preparation. Picture this. You're walking into the exam hall, the clock is ticking, the tension is high, and you are about to face a massive Cambridge computer science past paper question. We are looking specifically at syllabus code 0417. But listen, whether you are sitting for 0417, 0478, 2210, 9618, or 9626, the strategy I'm about to show you is your ultimate weapon. We are not just going to passively memorize textbook facts today. Absolutely not. We are going to learn how to build your case and argue your technical answers with the absolute precision of a top-tier courtroom lawyer. Examiners are the judges, and they are actively looking for concrete evidence, highly structured arguments, and undeniable conclusions. Today, we are going to completely transform the way you approach one of the single most misunderstood and poorly answered areas in information technology, actuators. By the end of this session, you'll have a systematic blueprint that leaves the examiner with literally no choice but to award you full marks.
Now look at this direct quote from a principal examiner report. This alert right here reveals exactly why so many hardworking students fail to secure those top grade boundaries. I want to introduce you to two archetypal students we see in the grading room every single year. Let's call them Alex and Sam. Now, Alex is brilliant at memorization. I'm talking flashcards for days. When a past paper asks a question about a pneumatic linear actuator, Alex's hand starts cramping up because they overload the exam paper with raw computer science facts. They basically regurgitate the textbook word for word. But here's the kicker. Alex provides absolutely zero analysis of the actual problem on the page. On the other hand, we have Sam. Sam is a rusher. Sam sees the word actuator, completely panics, totally misses the command word requirements, and scrambles to write a vague, rushed paragraph that doesn't actually answer the specific prompt. Both of these students walk out of that exam hall feeling pretty confident, and yet, both of them end up dropping massive, crucial marks. Why? Because they fell into the trap of providing generic answers. They completely failed to treat the exam question like a unique legal case that requires very specific, tailored evidence.
Here is our roadmap for today's session. We'll start with the actuator exam trap, move into cracking assessment objectives, cover the method mark strategy, jump into a deconstruct, solve, and evaluate workshop, review the top 3 examiner warnings, and finally, prove exactly why context is king.
Let's dive right into Section 1, the actuator exam trap.
So let's start our investigation by looking at the incredibly high failure rates surrounding actuator questions. Look, actuators represent the physical output of a computer system. They are literally the muscle of the machine. They are the components that actually do the physical work, turning digital electrical control signals into real-world physical action. Because they bridge that complex gap between digital logic and physical mechanics, examiners absolutely love to test them. It's a goldmine for them. But the trap is thinking that just defining what an actuator is will be enough to get you a passing grade. The examiner wants to see if you can evaluate which specific actuator is right for a highly specific scenario. You might wonder why separating key terminology proves so difficult when you're under the intense pressure of an exam. Well, the syllabus lists 9 specific types you need to master. Under exam conditions, candidates constantly mix up the power source with the motion type. Let's clear this up right now. Linear and rotary describe the type of motion, but hydraulic, pneumatic, and electric describe the power source driving that motion. Think about a robotic arm in a massive car manufacturing plant. It might use a heavy-duty electric rotary actuator for its shoulder joint to spin around, but it's going to use a pneumatic linear actuator for its gripping claw to grab a car door. If you simply write, "the robot uses an actuator," you immediately lose the mark. You must distinguish the mechanics and the energy source clearly and accurately.
Moving on to Section 2, cracking the assessment objectives.
To construct a winning argument, we need a behind-the-scenes look at how examiners actually grade your papers. Assessment objectives are the examiner's strict rulebook. They aren't just looking for what you know. They are actively tracking exactly how you think. If you don't decode the command words like identify, describe, or evaluate, you are presenting the completely wrong type of evidence to the jury. The syllabus explicitly demands that you step systematically through knowledge, application, and analysis, rather than just reciting isolated facts. This is where top students deploy the PEEL framework: point, evidence, explanation, and link. First, you demonstrate knowledge by making your clear point. For example, identifying the correct actuator, like a soft magnetic actuator for a delicate medical device. Then, you execute application by providing evidence and explanation. You detail exactly how the magnetic fields gently manipulate the soft materials without damaging human tissue, pulling those facts directly from the scenario provided. Finally, you deliver critical analysis by linking it all back to the core requirements of the question, perhaps evaluating why a rigid mechanical actuator would completely fail in this medical context. Now I'm putting 30 seconds on the clock. Look at your own past papers and see if you can spot which of your answers actually follows this Peel structure. It is a game changer. And hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's get back to it. The most crucial point here is that top-performing students exhibit a deeply connected conceptual understanding that transfers easily to completely unfamiliar contexts. Think back to our student Alex from earlier. Alex writes down 10 different perfectly accurate textbook facts about pneumatic actuators, but Alex doesn't explain how any of those facts apply to the specific factory automation scenario in the question. The examiner is not impressed by how many random facts you can remember. They are impressed by how deeply you can analyze the 2 or 3 facts that actually matter to the case at hand. This is the Computer Science Success Blueprint. It is a fundamental academic benchmark in Cambridge IT. You must prioritize analytical depth over superficial breadth. You must show logical, highly structured reasoning. One single, perfectly argued point using that Peel framework is worth far, far more than a bulleted list of disconnected definitions. When you start rewriting your answers with this depth, those harsh red pen marks will start transforming into glorious green check marks.
Let's look at Section 3, the Method Mark Strategy. This strategy right here is one of the single most powerful exam hacks you can possibly utilize. The method mark strategy is where you literally earn points just for showing your logical process, not just for getting the final verdict right. Yet it is astonishing how few candidates actively plan for it. The procedure itself, extracting the data, interpreting the technical relationships, and drawing evidence-based conclusions, is where the real points are won. It's essentially free real estate for your grades. Imagine you're asked to select and justify an actuator for an automated greenhouse window ventilation system. Even if your final recommendation isn't the absolute best choice, if you clearly document your systematic processing, identifying that the system needs a linear pushing motion, applying the principle that it must operate slowly and steadily to avoid breaking the glass, and analyzing the environmental factors like humidity, you are going to rack up method marks. Remember Sam, our student who rushes? Sam loses all of these easy marks by jumping straight to a one-sentence conclusion. Show your logical working, step by step, every single time. And listen, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCES to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCES and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, welcome back. By grouping these 9 specific actuators into a visual table, we encode the complex concepts into your brain so you can easily deploy them as hard evidence in your exam case. Think of this 3x3 matrix as your ultimate legal cheat sheet. On one axis, we have our primary motion types: linear, rotary, and soft. On another axis, we have fluid-based power, hydraulic and pneumatic, right alongside electric power. And finally, we have the specialized triggers: thermal, magnetic, and mechanic. When you can clearly visualize this matrix in the exam room, you can instantly cross-reference the exact needs of the scenario. Does the prompt describe a massive heavy-lifting construction crane? Boom! Your mind immediately goes to linear and hydraulic because of the immense force required. Does it describe a delicate, flexible wearable tech device for a hospital patient? Your mind jumps straight to soft and thermal or magnetic actuators. This visual story method prevents you from freezing up and gives you a structured way to pull data.
Which brings us to Section 4, Deconstruct, Solve, Evaluate.
Let's see exactly how this builds a rock-solid, evidence-based argument for the examiner. This 3-step deconstruct, solve, evaluate sequence is your standardized pathway for processing literally any complex IT problem they throw at you. Let's make this an interactive workshop. For our first challenge, the data scan. Imagine a complex data table on your screen right now detailing the speed, force, and precision of various actuators. You have a 60-second visual countdown timer in your head. Your first step is to deconstruct. Quickly scan and extract the core trend from the text and tables. What is the absolute heaviest load? What is the specific required speed? Next, you move to solve. You apply the relevant principles and break the massive problem into small, logical steps. Finally, and this is where the top-tier students shine, you evaluate. Check your findings for reasonableness and make justified recommendations. If your quick calculations suggest using a massive high-pressure hydraulic press for a delicate micro smartphone assembly line, your evaluation phase should catch that glaring, catastrophic error before you ever write it down on the answer sheet.
Top-scoring candidates act as hypercritical analysts here. They actively question assumptions and validate their decisions with strict, undeniable evidence. Let's do challenge number 2, find the flaw. You've got 60 seconds to look at this hypothetical sample paragraph. I chose an electric rotary actuator because it is fast. Where are the marks lost here? Time's up. The major flaw is that this answer completely fails to evaluate the evidence quality. It doesn't identify limitations. What if there's no continuous power supply in the scenario? It doesn't note assumptions. It's just blindly assuming fast is the only required metric. It completely fails to consider alternative interpretations. To get top marks, you absolutely must assess how these contextual factors affect your conclusion. Now, challenge 3, speed writing. You've got a 30-second timer starting now to conceptualize a perfect Peel paragraph. It would acknowledge that while an electric actuator provides the required rotational speed, its reliance on uninterrupted power is a massive limitation in an outdoor off-grid scenario. Therefore, you are logically justifying a mechanically triggered alternative. That is how you win the case.
Let's look at Section 5, the top 3 examiner warnings.
We've thoroughly reviewed the principal examiner reports from Cambridge, and there are exactly 3 major glaring warnings that consistently trip up candidates on actuator questions year after year.
Whether it's submitting incredibly vague details, completely ignoring proper formatting conventions, or totally forgetting the scenario, these are the most common pitfalls we absolutely must avoid. Let's break them down so you don't make these mistakes. Warning number 1, vagueness. Writing a sentence like, "an actuator moves things," is a guaranteed 0-mark response. Examiners want specific mechanical details. Exactly how does a pneumatic actuator use compressed gas to drive a piston in a linear motion? Warning number 2 involves the procedural framework. Students constantly forget to use proper headings, clear annotations, and correct technical terminology. If the exam specifically asks for a comparative table or a structured report format, and you just write a massive unformatted block of text, you are going to lose presentation marks regardless of how technically accurate your facts are. And warning number 3, which is honestly the most fatal error of all, leads us perfectly into our final and most vital rule of the entire exam strategy.
Section 6. Context is J.
The examiner alert we saw at the very beginning makes this undeniable. Notice how the generic answer merely lists textbook facts, while the top-scoring answer actively applies correct terminology directly to the highly specific problem outlined in the prompt. Let's look at a live transformation. Our student Alex writes, "A thermal actuator converts temperature changes into mechanical work. It is reliable." Guys, that is generic fact listing. That is 0 marks for application. Now let's completely transform that using our legal brief strategy. A top-scoring candidate writes, "In the context of the automated greenhouse ventilation system described, a thermal actuator is optimal. As the ambient temperature rises above the 25-degree threshold, the thermal expansion directly drives the linear mechanical opening of the vents without requiring external electrical power, ensuring fail-safe reliability during summer power outages." Do you see the massive difference there? We took the exact same core facts but applied them as evidence to the specific case. The red pen marks immediately transform into green check marks.
This is your ultimate takeaway to ensure your theoretical knowledge translates into maximum exam marks. Always link every single point back to the scenario. That is your complete bulletproof system right there. Decode the command word, apply the Peel framework relentlessly, and use your time management matrix so you don't rush like Sam or fact dump like Alex. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGSC to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGSC and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.
So as you review your very next past paper, I want you to ask yourself a serious question. Does your written answer present an undeniable, rock-solid, evidence-based case that the examiner literally can't help but reward? Have you mapped the specific motion type and the exact power source directly to the unique physical environment of the prompt? Have you critically evaluated the limitations of your chosen actuator? The evidence is all there in the syllabus. You just need to structure your argument like a pro. Take these exact strategies, go apply them to a 9626 past paper tonight, and start building your undeniable case. Until next time, keep analyzing, keep applying, and keep mastering the context. You've got this.